Question 14. A scientist is studying a population of mice on an island. The number of mice n in the population t months after the start of the study is modelled by the equation n is equal to 900 over 3 add 7e to the minus 0.25t, where t can be any real number but greater than or equal to 0. Part A. Find the number of mice in the population at the start of the study. So in order to do this, the start of the study is going to be where t is equal to 0. So all we do is sub that into the equation that we've got, and we find our value. So if t is equal to 0, we've got 900 over 3 add 7e to the minus 0.25 times 0, and plugging that into the calculator you just get a value of 90, so n is 90 for part A. Part B gets a bit more complicated. Show that the rate of growth dn dt is given by dn dt is equal to n lots of 300 minus n all over 1200. So the first thing we need to do here is differentiate. So we've got n is equal to 900 over 3 add 7e to the minus 0.25t. So we've got the quotient rule to use here. So that's where u dash v minus v dash u all over v squared is equal to dy dx. So u is the part that we have on top. So our u is 900. U dash, differential 900, just disappears, so it becomes 0. V is what's on the bottom. So we've got 3 add 7e to the minus 0.25t. Differentiating that, the 3 disappears. With exponentials, we differentiate the power and bring it to the front. So we have minus 7 over 4 e to the minus 0.25t. Applying that formula, we've got u dash v, which is just going to be 0. Take away v dash u. So we're going to have take away, brackets, minus 7 over 4 e to the minus 0.25t, all over 3 add 7e to the minus 0.25t squared. And so that is going to be our dn dt. Now we've got to try and get it into the format that they want. So the easiest way that we can go about doing this is to look at what we've actually started with and rearrange it slightly. So I'm going to rearrange it to say that 900 over 3 add 7e to the minus 0.25t is equal to n. So therefore 900 over n take away 3 is going to be equal to 7e to the minus 0.25t. And so subbing that in will give us a value of 900 over 4 multiplied by 900 over n minus 3 all over 900 over n squared. So then from here I'm going to say let 900 equal x, just so it just doesn't get as fiddly. And so we've got x over 4, lots of x over n minus 3 over n, sorry, minus 3n over n to combine that into one fraction, all over x over n squared. So expanding this bracket, we're going to get x squared minus 3xn all over 4n times n squared over x squared. So that's taking the divide over using keep, change, flip. So we're going to do top times top and bottom times bottom. So this is going to give us x squared n squared minus 3xn cubed all over 4nx squared. By factoring out xn, we can say xn lots of xn minus 3n squared all over xn lots of 4x. Now xn's will cancel. So this now gives us xn minus 3n squared all over 4x. And so subbing back in the fact that initially we said that x is going to be the same as 900 to make things easier, we now have 900n minus 3n squared all over 3600. And so therefore, just simplifying, we've got dn dt is equal to n lots of 300 take away n all over 1200. Part C says the rate of growth is a maximum after t months. Find, according to the model, the value of t. So this requires a little bit of thought. So if we're told that this is a maximum value, what we want to do is we want to maximise dn dt. So logically, in order to maximise dn dt, we need the numerator that we've got here as the biggest possible value. So if we say that that is our own equation, y equals n lots of 300 minus n. So y is equal to 300 n minus n squared. Then we could find the maximum by differentiating. Dy dn is equal to 300 take away 2n. Putting that equal to 0 to say 2n is equal to 300, and therefore n is 150. By finding that n is 150, we can then substitute that into our original equation in order to try and find out what our answer is going to be. So if n is 150, we can say that 150 is equal to 900 over 3 add 7e to the minus 0.25t. Rearranging that, we're going to get 3 add 7e to the minus 0.25t is equal to 6. And then we're going to get e to the minus 0.25t is equal to 3/7. From there, so we've got e to the minus 0.25t is 3/7, so we can take logs of both sides. We end up with the value of t is going to be minus 4 lots of ln 3/7. And so finding the exact value of that, t is equal to 3.4 months. Finally, according to the model, the maximum number of mice on the island is p. State the value of p. So all we have to do is we look at the equation that we have. So for part D, we've got the dn dt is equal to n lots of 300 minus n all over 1200. And looking at the top line here, we can see that if n is greater than 300, then what we know is that dn dt will be negative. Okay, and that's then going to mean that it starts decreasing. So therefore, the maximum is going to be 300.